Hello and welcome to Datathon 2024. My name is Pasha and we are AstrosDebugger's team. We had a really interesting project for this Datathon and I will tell you a little bit about general idea and pipeline, and Honk, my teammate, will tell you all about advanced part of the project and results that we achieved. So we picked the Astros track for this Datathon, and the main challenge for them was to see if traveling affects team performance. So of course, our first step to resolve this challenge was to answer two questions. First, how do we define this performance? And second was how this travel data is inferred in dataset that doesn't include travel information. On this slide, our pipeline looks very simple. Of course, we clean the dataset, then we do data exploration, and then after that, after everything is ready, we build the final model. But if we go deeper in code, it looks more advanced than like this just picture, right? So me and Honk will break down every step of our pipeline and show the results we achieved. So the first step was to clean our data. We dropped some entries from Japan to remove unrepresentative data or entries, right? Because there are not too many games in Japan, and calculating the distance would give us unproportional numbers. Then we dropped unnecessary columns because it doesn't help conclude whether the travel affect performance or not. And the final step in our data cleaning was we found that the most columns have a lot of outliers, but they are within reasonable constraint and they really don't affect our outcome. So we decided to keep them.
One of the first questions that we laid out from the start was where we can infer travel-related features from the dataset. Two information that we use as a reference from the dataset are game day, game date, and city, which gives us the locations away teams travel from, as well as consecutive rest day and game days. We also need some kind of measurement for performance. Here we are using on-base plus slug, or OPS. However, this gives an independent matrix, which does not necessarily reflect the change of performance, since bad teams would have low score and good teams would have high score. So we use the deviation of OPS values from a baseline, which is the average OPS, to decide when they are performing better or worse relative to the average performance. Next, because the dataset provides a pair of feature columns for each row, since each row is a game with data for two teams, that doesn't provide a lot for flexibility, and our focus is about what's affecting performance of a team. So instead, we separated the away and home team into different datasets and then stacking them along the same columns. Lastly, we one-hot encode the its array column to indicate home or away. This is the original dataset. As you can see, there are pairs of all the baseball game information. And this is when we separated them into different rows and changed the column names to merge both of them together. So using our new stack dataset, we group it by teams and its away to find what the average OPS deviation is for each team and for when they're at home or away to plot this graph. We can see that the teams generally perform better for home games than away games because the home game has positive values for deviation while the other has negative ones. So to test whether traveling has any correlation with this trend, we use a linear regression model with traveling features as predictors and predict the deviation from average performance. However, this is the resulted R-square metrics of this model, and it being negative shows that this model with traveling predictors is actually worse than using the mean as a predictor. So we conclude that there is a significant reduction in performance to play as an away team. However, traveling does not play a role in this trend.